Hey everyone, welcome to this lecture. We are going to discuss regarding NTP overview here. So NTP stands for Network Time Protocol, as we all know, and it is one of the important topic in networking. So whenever you have any networking devices like routers, switches, might be your end systems, firewalls, they will need to synchronize their local device time with the other devices, right? Or might be globally. So NTP is a networking protocol, as I've told you, and it is used to synchronize clocks. Its main job is to synchronize clocks, right? So this is the main job that the NTP does, is to synchronize clocks across your computer system. Okay. It ensures that all the connected devices, it will maintain accurate time, which is very crucial for system logs or security protocols when they are running, and any sort of scheduled task if you have to perform. Yeah. So the process how NTP works. So NTP works with the concept of with a hierarchical system of time servers that is organized into something called as stratum levels. So you'll have some time servers which will be organized into stratum levels. Okay, now this is something a key point to understand. So you can make the device who is requesting for the exact time will be called as the NTP client, and the device which will serve the time or synchronize the time to the requester will be called as the NTP server, right? So we'll have NTP client and we'll have NTP server. Okay, so let's say this is my user who is trying to synchronize its time. So this will be NTP client or the requester, and the server which can provide that response with the synchronized time will be called as the NTP server. So there will be a communication between the NTP client and the NTP server, right? So the NTP, as I've told you, will work on the stratum levels. So in this public domain, so you have got certain servers who can provide the accurate time globally. They are called as for example GPS clocks or atomic clocks, right, which can provide highly accurate time sources. Okay, and they are grouped into the stratum level called as stratum level 0. Okay, so this is say stratum level 0, or we can say stratum 0. Okay, so which will provide highly accurate time sources, right? Example could be atomic clocks or GPS clocks, etc. Okay, now any device which is connected to that particular stratum level 0, right, will be receiving the exact clock, right, or exact time info. So what do I mean is, let's say we have got here certain devices who is requesting their time. So basically they will synchronize, or they will get their time synchronized from their upper level stratums. Okay, so these devices who is requesting, they will be part of stratum level 1. Okay, so this is part of stratum level 1. Okay, now likewise you have the stratums defined like this. You have further the stratum levels are defined like this. So you'll have stratum level 2, stratum level 3, and so on. So let me write down it here: stratum level 2, stratum level 3, and you have got the devices who is requesting for or who is willing to do some time synchronization, right? And synchronization can happen in this direction as I'm showing here, from the top to the bottom, right? Or it can happen in these directions as well within the stratum level devices, right? So one can act as a client, another can act as a server. Okay, so yeah, as I've told you, so stratum 0 devices will provide you the highly accurate time sources like atomic clocks and GPS clocks. Stratum 1 level devices, or stratum 1 level servers, they directly connect to stratum 0 sources. Likewise, stratum 2 level servers will synchronize with stratum 1 servers, and likewise stratum 3 or 3 plus servers will synchronize with their higher level stratum, and continuing the hierarchy in a down manner. So lower stratum devices will get their time from higher stratum servers, which will maintain the network wide synchronization. Okay, so regarding the synchronization process, you have got uh, multiple steps. So it is basically the time sync process. So what are the steps involved? The first thing is your client, the NTP client will send request. So we have NTP client request. So a device that is the NTP client will send a time request to an NTP server, right? So send time request to an NTP server. Now, for example, this device, who is requesting its time, let us say this device is requesting its time, it can request from multiple NTP server, right? So it can request the time from stratum level 1 as well as from stratum level 2, right? Had the stratum level, the responses that it gets from the lower stratum level value, I'm sorry, so this 1 is lower, considered lower from 2. So once you get the stratum levels from the lower numbers, it is considered better, okay, or much more accurate. All right, so likewise, this is a client request. Then we'll have the server response. Number 2 would be the server response. So server response, basically the server will provide the accurate time, along with delay calculations, right? Time to reach to that NTP server, or basically delay calculations. Then we have another process called as clock adjustments. Okay, in case of clock adjustment, what happens is the client will adjust its clock based on the received data. The client will adjust its own clock based on the received data. And the fourth and the last process is doing a continuous sync, which means the client will periodically check and adjust the time to maintain accuracy, right? The client will periodically check and adjust time to maintain accuracy. All right, okay, so certain key features. So this is the time sync process. Last but not the least, let me tell you certain key features of NTP that is available, right? First thing is something called as clock drift correction. This is one of the features that you get from NTP, where gradually it will adjust the time rather than making sudden changes. So the time is gradually adjusted. Then you can do multiple server queries. Okay, that means the client can consult multiple servers to avoid relying on a single source for its time synchronization. Number 3 point could be security mechanisms involved with NTP. So that means that authentication is supported. right? Authentication is supported. Okay, that means the user can authenticate to prevent, malicious time manipulation. So you can have, authentication credit. If you enter the right authentication credentials, then only you can get connected to the right, stratum level servers and sync your time. And fourth point could be the UTC standardization. Okay, which means that it will synchronize the time based on the coordinated, universal time. Okay, which is space is UTC, right? You can, in your Windows PC or device, you can give, various NTP commands. So one of the command to check would be NTP q space -p. It is used to check the time sync status. Likewise, you can give the command called as second command called as NTP update, followed by the server address, which could be a URL or which could be an IP address. Okay, if you are defining URL, ensure that your device has the DNS configured properly to reach to that URL. And you can restart the NTP service, where you can say system CTL, restart NTP to restart the NTP service. Okay, so yeah, I hope it is clear regarding NTP, and you can apply this discussion in your any configuration aspect. So when you're configuring Palo Alto as an NTP server, you can do that, or might be you're configuring any Cisco devices as an NTP server, you can do that. All right, so I hope it is clear. Thank you for joining. I'll see you in the next lecture.